And now I have the difficult job of introducing Richard Hawkins. He's already been introduced several times today, mention of the SACE work that is done. I notice he's been the co-author on a number of the papers that have been presented by other people. Richard is a senior lecturer in computer science at the University of York. At the university's Center for Assuring Autonomy, his research focuses on safety assurance, safety cases, and so on, particularly for autonomous systems and AI. Previously, he worked as a software safety engineer for BAE Systems and an advisor in the nuclear industry. And he's going to talk to us now about whether the safety case techniques that we're using at the moment are adequate given the criticism that is coming out of some of the poorly produced safety cases, I understand.
Okay, thank you. So thanks for everyone sticking around to the bitter end. So I'll try and keep this light. It's good to see so many people still here. Okay, so what this talk's really about is kind of my thoughts on how we can get better than we currently are at creating effective safety cases. So we're able to make safety cases work for the types of systems that we're having to kind of deal with at the moment. So I think safety cases are more important now, to be honest, than they've ever been. So I'm thinking of dealing with kind of safety of autonomy, safety of systems using AI, where we've got very dynamic systems, very interconnected systems, and all of these fast-changing technologies that we're trying to use. So I think safety cases are now really important. However, this requires that safety cases are used well. So they're just like any other tool that we have. So no matter how good safety cases are as an approach, if they're going to be used badly, then they're not going to be effective. And I think safety case practice often, from what I hear and what I see, often is still quite poor. So there are clearly some pockets of really, really good practice out there. But I think there's also clearly a lot more probably bad practice going on. And I think many of the criticisms that we all hear about safety cases, I think they are probably fair, to be honest, based on some of what we see going on in safety case practice at the moment. And I'll come back to those kind of criticisms in a minute. But I do think that safety cases already have everything that we need to deal with the kind of systems we want to deal with. So I don't think we need to start from scratch and kind of reinvent the wheel on any of this. I think we already have all the tools that we need at our disposal. What we need to do is get better at using those tools that we already have. So I think what we need actually is better processes to ensure safety cases are effective. And I'll talk in this presentation about what I think those processes need to look like. And just to be clear, this isn't me trying to create something new. What I'm trying to do really is try and understand and articulate what that good practice is that's out there in safety case development processes and what they need to be. Okay, so we've talked about these problems and safety cases not being used effectively. And this is something actually that we've all known about for a long time. James already mentioned the Nimrod review by Hatton Cave. So this was the review into the crash of the Nimrod in Afghanistan in 2006. And it came up with lots of really, really interesting findings about lots of things. And amongst those was some discussion about the role of safety cases in that accident. And it said lots of very insightful things. I'm just going to highlight a couple of things that were said in there. So this is taken directly from the report. So if the Nimrod safety case had been prepared with proper skill, care and attention, the aircraft would not have been lost. Unfortunately, the Nimrod safety case was a lamentable job. It was riddled with errors, missed key dangers, and was essentially a paperwork exercise and virtually worthless as a safety tool. So a couple of things to note about this. Firstly, it doesn't say safety cases are a bad idea. Actually, it's saying the opposite to that. But what it's doing is highlighting the need for safety cases to be used well. And it's saying that, well, particularly in this case, it clearly wasn't. Safety cases weren't being used effectively. Another thing I can pull out of here. So it says, we need to focus attention on the fact safety cases are about managing risk and not assuming safety. So this is highlighting a problem with safety cases where people start from an assumption the system's already safe. And as a result of that, we end up with very weak safety cases. Okay. Now, obviously, this was quite a while ago now, but there's more recently been a lot of people, well, been some people who've identified essentially very similar kind of criticisms to that. Probably the most high profile voice of criticism on how safety cases is used, as many of you will know, has been Nancy Leveson. And she's written some papers laying out her thoughts on what some of these problems are. And what we can do is actually pull out essentially the same common themes that keep coming up. And I'm just going to pick out a few of those just to quickly highlight what those problems are. So I'm going to focus on three. The first one is confirmation bias. So you probably all know what confirmation bias is: seeking out evidence to support a predetermined conclusion whilst tending to ignore information that may be contradictory. And I think current practice is encouraging confirmation bias with this idea of starting from this presumption that the system is already sufficiently safe. So good safety cases require us instead to focus on also understanding why a system's unsafe and not just why it's safe. Another problem that's highlighted is what Nancy Leveson calls after-the-fact assurance. So often I think current practice views a safety case as something that you create at the end of the life cycle. So once you've done most of your development work. And the problem with this is it gives us no opportunity at all for the development of the safety case to actually have any influence over the design of the system. Okay. This also increases the likelihood that we're going to have confirmation bias. Because it essentially increases the pressure on you to we just need to show this system safe because we need to get it out and get it deployed. And then the third one that's often picked up on is this idea of safety cases as a paperwork exercise. So safety cases just purely, it's all about creating a document. And if we treat safety cases in this way, they can't possibly play an active role in development and assurance of safe systems. And this is where they end up literally of very little value to the safety of the system. And also it's likely to mean we produce them after the fact, and therefore they're going to be subject to confirmation bias. So all of these things, I think, are interrelated. So what do we need to do about it? Well, I think what we need is safety cases that are risk focused. That safety cases that try and identify ways in which the system may not be safe, rather than just assuming that it is. Safety cases that drive safe design and operation of the system, so influencing the system itself rather than just documenting what's already there. Safety cases that will support decisions that are made throughout the life of the system. And encouraging people to think about and to understand why their system is safe, and also getting people to think about when it's not. So I think there's a really important role for safety cases in just making people think about their system. And by people here, I mean the actual developers of the system and the operators of the system themselves, not just the people involved in the safety case process. Okay, so what do we need to do to achieve this? Well, I think we need to get better at creating safety cases. And as I've already said, I don't believe that what we're lacking in is tools and techniques. There's loads of stuff already available to us. And in some ways, maybe we need to stop inventing new things and get better at using what we've already got. So I think it's how they're applied that's leading to the bad outcomes. So talking about these tools and techniques and stuff we already got, probably worth me just saying the kind of things I mean. I think most of these won't be a surprise. And I think a lot of these will be very familiar to people here, so I'm not going to dwell on them, but I just want to tell you what I'm thinking of when I say this. So we have notations for explicitly representing argument structures, such as goal structuring notation. We have methods for applying the notations to create arguments. So we've got things like the 6-step method, which has been around for a very long time now. We also have ways of capturing challenges to arguments and ways of documenting things like rebuttals. And we can use dialectic arguments to do that. We've just heard about techniques that we have for splitting safety case into risk and confidence arguments, so we get a clear focus on risk at the core of the safety case. And then the other good thing about following Jane, she's also just talked about how we can link these operational arguments into our design safety case. And what we also have, which again is something that was been mentioned a lot throughout this conference, is ways in which we can establish through life monitoring of the safety case. So we know if that safety case becomes invalid through things that are happening during operation. We've heard talk about things like safety performance indicators and so on. So we already have all of these things at our disposal. And I think this does give us more than enough to do what we need to do. So clearly these aren't being used effectively. So what we really need to think about is how do we bring all of these kinds of things together and make them work for us so we can create better safety cases. So I think what we need is to think about the process. What's good practice when it comes to a safety case process? And this is what I think it maybe could look like. So as I said earlier, what we're trying to do really is understand and then build on existing good practice. So you can see on this picture up here, we're extending the 6-step method, but we're trying to enhance it with these additional steps that are explicitly incorporating review and challenge and update as part of an iterative safety case development process. And you can see it's got 6 stages. And what I'm going to do is just briefly, in the time that's available, go through each of those stages and explain how I think these work in practice. So we start up here at stage 1. So as I said, this using the existing 6-step method in order to create that risk argument, which is going to be the core of our safety case. But the key thing here in the way presenting this process is that the safety case developer has to essentially pause after each cycle of that 6-step method. So with each level of decomposition of that risk argument, you need to just kind of stop and think. So, and then go through these other stages in the loop before returning to stage 1 and then developing the next level of the risk argument and so on. And it's this stepwise iteration that's crucial to this process that I'm showing up here. Because the intention, remember, it's not about assuming that the claims we're making in that risk argument are true. The output of stage 1 is really a proposal about how the risk claim might be supported. And then this is going to then be deliberately challenged and updated in the subsequent steps as we go through that process. So the other good thing about following Jane is that she's already explained our example, which makes things a little easier. So if we think about stage 1, what are we doing? Well, we're just creating that first level of the risk argument. And if we use the infusion pump example again, so as Jane said, we've got our claim at the top about the safety of the infusion pump. We've got some context here for that claim. And then this is just the risk argument. So all we're doing here is a really simple argument over each of the hazards that we've identified in the hazard log. And you can see at the bottom here, we've got claims about each of those hazards. And that's it. That's all we do at stage 1. We got that first level of decomposition of the risk argument. And then we can move on to stage 2. And this is really the core of what we're trying to say needs to be done here. So the safety case developer now identifies what the possible challenges to that risk argument might be that they've started to now develop. So this is trying to enforce this discipline of continuous self-review throughout the argument development. So we're trying to, as the developer of the safety case, identify reasons why our own risk argument might not be true, or why the confidence in that might be undermined in some way. So go back to our example here. I can start to think about ways in which my argument might be challenged. So challenge here. So we've got here, this is our design document that describes the infusion pump. Well, that might be challenged because actually the pump that we produce that actually gets shipped out to people might be different from what was in the design document, okay? So that would challenge the validity of the argument that we've put forward. Also, once it's shipped, it might be fine when it leaves the factory, but then what happens if it gets modified when it's in use? So again, that's a challenge that we could predict could undermine our argument. Over here on the far side, hard to do that from a distance. On the far side there, we've got the context that talks about the usage. So we're defining this as being used as in accordance with the user guide. Well, what happens if someone uses it in a different, unplanned manner? And then we've got our hazard log there, which is pretty important. Well, simple question, what if that's incomplete? And actually in this case, which we've got the CE1 at the bottom, we've looked in the hazard log and actually we've realized that it's not complete. So we know that there's been reports of a hazard and we can't see it in the hazard log. Okay. So this makes all of this look quite a formal kind of thing to do. But actually, that's not what we're saying. So all we're saying here really is stop and think as you're developing the argument. So before you move on developing your argument, think about how what you've proposed already could be challenged or could be defeated. An important thing is, should be doing this anyway. Okay, so I believe this is what good practice is already doing. Okay, maybe not in a kind of systematic way like we said here, but I think this is what good practice is doing. Clearly, lots of people aren't doing this. So before we go on and develop our risk argument, we need to think about how these challenges are dealt with, and that's what we do at stage 3. So thinking about how we're going to address each of these challenges, and I think there are essentially 5 options that we've got for how to do this. So firstly, we can rebut the challenge. So we can show why the challenge isn't valid for this system or show why it's not significant. We can make a change. So we can make a change to the system itself or make a change to the risk argument to try and address that challenge. We can introduce a confidence argument to demonstrate why we're confident that the thing that's challenged in the risk argument's okay. So we could reason about the processes we've used and so on. We could introduce an operational argument to demonstrate how that issue is going to be handled safely during operation. Or we could do some introduce some monitoring of the system to check whether that challenge does actually come to fruition when the system's operated. So if we think about how we might address each of these challenges, so challenge 1 there, what we'll need to do is show that we'll need to show somewhere in the safety case that the pump design document is a true representation of the pump that's been manufactured. So we can introduce a confidence argument to consider how that design document was created, how it's been reviewed, so on. For challenge 2, so in this case, we can talk to the development team and they're able to confirm to us that due to the way this pump's been designed, actually there isn't a credible way in which the pump can be modified once it leaves a factory. So effectively, we've got a rebuttal to that challenge. For challenge 3, we'll need to demonstrate somewhere that the people that use the pump are going to be following the guidelines in the user guideline. So this is somewhere where we maybe require an operational argument. And challenge 4, I think there's actually 2 distinct strategies that we would maybe need to take there. So firstly, we need to show why we think the list of hazards in the hazards log's complete. So we again could look at putting a confidence argument in, but also we're going to need to monitor this so that we can check for the occurrence of any new hazards, which might only have become apparent, for example, once the pump goes into operation. So we need to know that we'll be aware of that. And then the final one we had, which was this report of a hazard that wasn't in the hazard log. Well, obviously, we'll need to update the hazard log so that we can include the new hazard. But this will also have a knock-on effect on the risk argument itself. And we're going to see that in a minute. Okay, so we then move on to stage 4, which is simply we have to implement those strategies that we've identified to try and improve this safety case that we've started building up. So we can again go back to our example and think of what we've done. So we've added in ACP1 here. So this is where we'll establish the confidence argument relating to challenge 1. Down here, so this is our rebuttal that we talked about for challenge 2. And if we like, we can document that in the safety case. So we've got this dialectic notation that we can use if we want to show that explicitly. Over here, OCP1. Okay, this is where we link to the operational safety case, showing that the usage guidelines are being followed. And then over here, we had the hazard log. Okay, and we talked about those two things. So we've got both the confidence and operational arguments, ACP2, OCP2. And down here at the bottom right, we've updated our hazard log. So that counter evidence that we had about that new hazard, we can now essentially say that that's been rebutted as well. Okay. So what we've had to do here is essentially update our risk argument to deal with those things that we've identified. Okay. So what do we now do? Yeah. So we've completed stage 4. And we can continue to develop our risk argument. So we can go back to stage 1. And what we'll then do is repeat those stages, go around that loop again. And we can keep going like that until the risk argument's complete and we have evidence to support all of our claims. One of the things I think it's worth looking at here is the fact that we've had to actually make a change to our risk argument. So you see down here, we updated our hazard log because we found a new hazard. And in this case, we've had to introduce a new claim to reference that. So we've now got a 4th claim at the bottom here, which is this new hazard of allergic reaction, which we've added in to our argument. Okay. The other thing you'll notice is that we've chosen here, just to keep it simple, not to show those dialectic aspects. So if you want to, you can leave those in and show where you had challenges, where you've got rid of them, or you can choose to take them out to make it the argument clearer, and you can make that choice. And as Jane talked about before, where we've got these OCPs, ACPs, essentially what we're doing are linking off to these arguments, either our confidence arguments or our operational arguments in our operational safety case. So we've got 2 other stages in our process here. So stage 5 is about independent review. So what we've seen in the process going around that loop of stages 1 to 4 is that self-review is essentially inherent within this process. So reviewing our own argument as we're developing it. But being effective with a safety case process requires us to have independent review as well. So this is by people who aren't actively involved in the development of the safety case. And I suppose one thing to note here is that you could jump out to this independent review stage at multiple points as you're developing the argument, and then, you know, kind of jump back in and resume around the loop. And that's what's indicated by that dotted arrow there. And then finally, we got stage 6, which is about continuing to monitor the validity of the safety case, and if necessary, updating it throughout the life of the system. And we could get various challenges that might come to the validity of the safety case through, for example, new counter evidence becoming available, or changes to the system, or changes to the way we operate the system, or through our safety management activities that we're performing through life, we might identify challenges to our safety case there as well. Okay, so that was very, very rapid walk through that because of time constraints. I've written this process up as a paper where I'm able to go through, explain in a bit more detail how I see this working. So you can go and have a look at that if you want. There's a link there. You can download it and let me know what you think. So just some conclusions. So I think, as I've said, I think more guidance is needed on how we can make use of these existing safety case tools that we have in order to create better safety cases. And what I've tried to do is describe a process for doing that. I'm trying to reflect what I see happening in examples of best practice that I've seen from people who are doing a good job of this. What is it that they tend to do? And I think all of this is more important than ever, really, to make sure that safety cases not just going to get better for existing systems, but that they're going to remain fit for purpose. As our systems are getting ever more complex, we need to get better at how we do safety cases. And I'm particularly thinking about increases in the use of autonomy, more interconnectivity between systems, and this idea of more dynamic, rapidly changing systems. And happy to take questions.
Thank you very much. I imagine, yes, we have a lot of questions. I'll start over there. That was the first one I noticed.
Thanks, Richard. James Inge. Your last point on the conclusions, you mentioned the dynamic and rapidly evolving systems. And I know there's a lot of interest in automatic generation of safety cases. And I can see the attraction of reducing the drudgery. And also, if you're going to have a continuous integration system and you want to be able to iterate changes through, but that seems to detract from thinking about the problem and challenging and reviewing. How do you see that tension evolving as we go forward with more complex systems that we're developing more in a more agile way?
I think actually too much automation of safety case process is probably a bad thing. I was talking to some people about this earlier, actually, and it goes back to this idea of, you think about what we're trying to do almost with that process is getting people to think about why their system's safe, but also focusing on what might make it unsafe. And if your safety case process ends up coming down to press a button and generate a report, all of that's gone from the process. And it kind of, does it actually defeat the point of having a safety case at all, would be my question. So I know that we need tools to support this, and we need to make it easier for people to develop safety cases, but I think we have to be careful how far we go. It would be my answer.
Yeah, so yeah, Nancy Leveson does have a tendency to be hysterical in her condemnation of safety cases, and I've heard her rant about those dangerous people in Europe who use safety cases, and she does have a tendency to set up strawmen.
Mm-hmm.
And a lot of her arguments aren't against safety cases, they're against poorly written safety cases.
Absolutely.
And we all agree that poorly written safety cases are dangerous.
Yeah.
But that doesn't. But I think we can easily overlook that I think she does have one really good point, which is that if the task we're given is to create a hazard analysis, then we naturally, human nature is to find as many hazards as we can. Whereas if the task we're given is to write a safety case, then human nature is that we come up with many reasons for why the system is safe as we can. Mm-hmm. And I've seen I've seen poorly written safety cases where the authors come up with as many reasons why the system is safe as possible. So I liked what he said in stage 2 about coming up with challenges to the safety case. But to do that effectively, don't you need a second team? Don't you need one team to come up? In fact, it would almost be better to do it the other way around, to have one team come up with an argument as to why the system isn't safe, and then to have a second team come up with a counter argument to try and rebut the unsafety case, if you like.
So I think when I said this is a safety case developer reviewing their own safety case, I guess I meant the safety case development organization, really. And I suppose using 2 teams as a better way of challenging existing arguments, it might be an effective way of doing stage 2. So having other people to do it.
Yeah.
So, I mean, Haddon Cave actually said we should call them risk cases, not safety cases. This was one of the, and we never did that, which I think was probably the right decision. But the whole point of that was moving this focus onto thinking more about why it's unsafe. Now, I think some people have also come up with other notations and approaches for that, which make negative claims and then try and show why they're defeated. I just don't think we need to do that, because I think we can do it. Like you say, if we do stage 2 of this correct, actually, we were already doing that. We just weren't very good at doing it. Yeah. But I think, maybe having a kind of adversarial prosecution and defense and just let them but that can be people within the same team, can't it? It doesn't have to be external people.
I kind of feel 2 things. One is that it needs to be somebody different, because otherwise you're going to do what Nancy does, which is come up with strawmen and weak arguments that he can easily counter and say, look, we've knocked all these strawmen down. You need someone whose focus is coming up with as good an argument as possible as to why it's not safe. And I kind of almost think maybe that should be stage 1 and not stage 2.
Yeah, I think you need a proposal to throw bricks at, and that's what stage 1 is providing.
Yes, perhaps I could just answer one question there. I'm working with an external company at the moment. They've produced a safety case, but their stage 2 almost seems mechanized. That it's a software system, and you might have made mistake X in the software. You might have made mistake Y in the software. You may have made mistake Z in the software. So there's an enormously long list of things that, yes, indeed, you could have done wrong in the software, each of which then has to be rebutted. It seems that you can go over the top with stage 2. I'm not sure what your comments are.
Well, I thought one of the questions I might get is about the tractability of stage 2, right? And my response to that was going to be essentially that you have to use some judgment. I mean, with if you go over the top every claim, you try to find every possible. But what we're trying to do is to create a good safety case. So try and identify what are the most credible, the most important. If this did happen, what would have the biggest impact on the safety, rather than worrying about going down through everything. So I think there's a judgment that needs to be made on what's proportionate.
Well, I'm afraid I took the last question there. I apologize for that. And well, thank you again.
Okay.
Thank you very much indeed.